Assalamualaikum and hi everyone. We are from Group 4. We are presenting production of formaldehyde from methanol. Before we start our presentation, we would to introduce our group members. First of all, we should know what is formaldehyde. Formaldehyde is when methanol and air are combined with a catalyst such as silver or metal oxide. Formaldehyde can be created, and it is important industrial chemical that finds extensive use in various industries. Because of its high reactivity and versatility, it is used to manufacture a wide range of items for the home, business, aviation, pharmaceuticals, and cars. So, this is PFD from production of formaldehyde from methanol. As you can see here, in this production, formaldehyde is typically produced through the catalytic oxidation of methanol. The process involves passing methanol vapor over a silver or iron oxide catalyst at elevated temperature. For example, methanol plus oxygen produce formaldehyde plus water. Therefore, this reaction is exothermic, so that means it releases heat. The instrument that we apply on this PFD are methanol pump, methanol reboiler, air boiler, air heater, gas mixer, off-gas heater, gas filter and flame arrestor, water heat boiler, reactor, steam distributor, and the last one is absorber. Did you know one the possible explosion might be happen at the reactor? For your information, exposure to formaldehyde can occur through inhalation, injection, or skin contact. It has been classified as a human carcinogen primarily due to its has association with certain cancers. Common sources of formaldehyde exposure include certain building materials, tobacco smoke, and household products. Proper ventilation and minimizing exposure are crucial to reducing potential health risks associated with formaldehyde. So, we will move to the calculation. The input on this process is methanol plus oxygen. Meanwhile, the output is formaldehyde plus water. First, we assume that the mass for methanol is 1000 kg. And then, we need to find the number of mole for methanol. We use the formula number of mole equal to mass over mass weights. And then, we got 31.25 kmol for the answer. And then, the ratio for methanol to formaldehyde is 2:2. It is because on the chemical equation, methanol have 2 mole and formaldehyde also have 2 mole. Next, we need to find the mass for formaldehyde. We still use the same formula, and then 31.25 kmol times 30 kg per mole, and then we got the answer is 937.5 kg. The ratio for methanol to water is 2:2 because water also have 2 mole on the chemical equation. Next, mass for water, 31.25 kmol times 18 kg per kmol, and we got the answer 562.5 kg for mass water. As we know, input equal to output, so to get the total output, the mass of methanol need to mix with the mass of oxygen. So 937.5 kg plus 562.5 kg equal to 1500 kg, and then the mass flow rate for the output is 1500 kg per hour. We already got the mass of methanol, formaldehyde, and water, so we need to find the mass of oxygen. 1000 kg plus oxygen equal to 1500 kg. So the mass of oxygen we got 500 kg. From the balance equation, we can ensure the mole ratio between reactant and products. First thing first, we find the amount of moles of each reactant. Next, use the coefficient from the balance equation to establish the mole ratio between the reactant. Compare the actual ratio of moles of reactant to the ratio given by the balance equation. So, the result is we find that the methanol that is completely consumed is the limiting reactant. This is because they have the smallest stoichiometric coefficient in the balance equation, or gives the smaller amount of product. Meanwhile, the oxygen is the excess reactant.
Then we'll have process description. Firstly, methanol is pumped and then go to the methanol reboiler. Because of the vaporization process occur in this reboiler. After the process, methanol will go to gas filter. Air and also methanol will be mixing in this pipe before going to gas filter and flame arrestor. At this equipment also have an addition of oxygen. After that, all of the substance will go under mixing process before going to reactor. Silver will be added as a catalyst. After all the reaction, they will be separated to steam distributor and absorber. Steam distributor will be recycled to the gas mixer. And lastly, absorber will be separated into pure formaldehyde solution and water. The water will be reused to the gas mixer and the process will be a recycle process. So next we have the diagram. Firstly is methanol vaporization. Methanol is vaporized to form a gaseous feedstock for the reaction. Secondly, oxygen addition. Molecular oxygen is introduced into the reaction chamber. The molar ratio of methanol to oxygen is carefully controlled to maximize the yield of formaldehyde. Thirdly is catalytic reaction. The gaseous mixture of methanol and oxygen passes over the silver catalyst where the catalytic oxidation takes place. Nextly is formaldehyde formation. Methanol undergoes oxidation to produce formaldehyde and water is formed as a byproduct. Lastly is a separation and purification. The product stream consisting of formaldehyde, water, unreacted methanol and other byproducts is then separated and purified to obtain a high purity formaldehyde stream. So what problem that can occur in industries? The problem that can be occur in industries are miscalculation of the processes, poor storage conditions and the less effective catalyst. So to prevent the problem, the process variables such as temperature, catalyst type and amount, and feed composition need to be optimized. The mass and energy balance can help to track the flow of material through a system or process. It can be used to design, control and monitor chemical processes as well to assess their environmental effect. In conclusion, the production of formaldehyde from methanol through catalytic oxidation is a complex and critical industrial process. The efficiency and yield of this process are influenced by numerous factors including reaction condition, catalyst performance, feedstock quality, and overall process design. Addressing challenges and implementing improvement is essential to enhance the overall performance of the production process. By addressing challenges, the industry can achieve higher yields, improve efficiency, and a more sustainable production of formaldehyde from methanol. That is all from us. Thank you for listening.